Hi guys, so we're going to finish up chapter 5 by moving on to lesson 5.6. So let me present my screen and we'll get started. Okay, so this function we're going to be talking about inverse functions. So let me get rid of that. So very simply put, inverse functions are functions that undo each other. So functions that undo each other. All right, so let's move on to the horizontal line test down below. The inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. So you might remember from Algebra 1, so side note real fast, if I give you a bunch of graphs and ask you whether or not these represent functions, right? If each of these are a function, we learned in Algebra 1 the vertical line tests. Vertical line tests. So in order to determine if this is a function, we would draw a bunch of vertical lines, and as long as each vertical line only intersect the graph at one spot, then we knew it passed the vertical line test and it's a function, okay? And that's a linear function. Here, if I use the vertical line test, each vertical line only intersects the function or the graph one time. So we know it passes a vertical line test, and this is a function. It's the absolute value function. All right, same with this one here. If I draw a bunch of vertical lines, each vertical line only intersects the graph in one spot. It passes the vertical line test. We know it's a function, and we know that's a parabola, and it represents a quadratic function, okay? So that's how you determine whether or not a function, or excuse me, that's how you determine whether or not it is a function. If you want to determine if this function has its inverse is also a function, you use a horizontal line test. Okay, so here I have a parabola. Okay, it's a quadratic equation, right? It represents a quadratic function. I know that it is a function, but if I want to know if the inverse is a function, I use a horizontal line test. And you can see they already drew a horizontal line, but any horizontal line I draw, right, it intersects the graph in more than one spot. So it doesn't pass the horizontal line test. Therefore, the inverse is not a function. All right. For this one, if I draw a bunch of horizontal lines, it only intersects the graph one time. Each horizontal line only intersects one time. So that means that the inverse of this function is a function. Okay, so that's the horizontal line test. All right, I do want you to write a few more things below. Let me just scroll down. When original function contains an even index, right? So we're talking about the root. Ooh, went off the page a little bit there. All right. You must restrict the domain of the inverse because it's a parabola. All right, and this will make more sense once we get into the problems in just a minute, but just make sure you note this. And again, I'll make this more clear when we're going through the examples. But when the original function contains an even index, so if it's a root 2, a root 4, you must restrict the domain because the inverse is a parabola. Okay, so let me erase that. All right, so we're going to jump into some problems here. It says in exercises 1 to 3, solve y equals f of x for x, then find the inputs when the output is -6, okay? So inputs, when we talk about inputs, we're referring to the x values. Hopefully you guys know this from Algebra 1, but just as a quick review. And when we talk about the outputs, we're referring to the y values. All right. So it says solve y equals f of x for x. So you're going to change the function notation, change it into y equals 2x minus 1. And it says solve for x. So you just want to get x by itself, isolate the x. So I'm going to add 1 to both sides. Nothing crazy here, just how you would normally solve for the variable. So I have y plus 1 equals 2x. Then I'm going to divide both sides by 2. So I have x is equal to y plus 1 divided by 2. Okay. Then it says, then find the output then the input, x value, when the output, the y value is -6. So when the y value is -6, what is the x value? What is the input? So x is equal to -6 plus 1 divided by 2. So you have x is equal to -5 over 2. All right, so again, it says find the input, the x value, when the output, the y value, is -6. You simply have to plug in -6 for y. Okay, so that's number 1. Let's try number 2, same idea. So first change it into y equals 1 minus x squared, and then solve for x. So I'm going to subtract 1 from both sides. So I have y minus 1 equals -x squared. Then I'm going to divide everything by a negative. So -1, -1, -1. So I'm left with x squared is equal to -y plus 1. All right, then I'm going to take the square root. Don't forget, when you take the square root of both sides, you need to do plus minus. So it's plus minus -y plus 1. Okay. And then from there, you're just asked to find the input, find the x value, when the output, the y value, is -6. You're going to plug in -6 for y. So x is equal to plus minus the square root of -6 plus 1. All right, so swing it up here. I have x is equal to plus minus the square root, and that's going to be just a positive 6 plus 1, which is 7. You can't take the square root of 7, so you just leave it as x equals plus minus the square root of 7. And the last one of this type. Again, when you're asked to solve for x, you're going to change function notation into y equals x minus 1 cubed plus 2. So solving for x, I'm going to subtract 2 from both sides to start. So y minus 2 equals x minus 1 cubed. Then I have to take the cube root of both sides. So I have the cube root of y minus 2 is equal to x minus 1. I'm going to finally add 1 to both sides. So I have x is equal to the cube root of y minus 2 and then plus 1, not under that radical. All right, so that's part 1 of this problem. Part 2 says, now take that equation and replace the y with -6. The output, which is the y value, 6, find the input, which is the x value. So I have x is equal, I think I'm going to run out of room actually if I try to do it there. So let me move it up here a little bit. So I have x is equal to the cube root of -6 minus 2 plus 1. -6 minus 2, that's going to give you a -8 under radical. So y is equal to the cube root of -8 plus 1. All right, the cube root of -8 we know is a -2. Just erase that. So I have x is equal to -2 plus 1. So x is equal to -1. All right, so that's the first 3 problems. Next, it says, find the inverse of the function, then graph the function and its inverse. We're going to just use our graphing calculators to graph these, okay? So finding the inverse of each function. If you remember this from Algebra 1, because you did find inverses functions in Algebra 1 is basically 2 steps to find the inverse, and we did it above. You're going to, well, we practiced doing it above, kind of got started. You're going to switch, you're going to switch X and Y, and then you're going to solve for Y. Okay, so if I ask you to find the inverse of f of x equals 10x, okay, first change it into y equals 10x. So change it into, from function notation, just replace the function notation with a y. And then to find the inverse, what you're going to do is switch the x and the y. So it's going to be, let me write inverse over here so you know what I'm doing. I'm finding the inverse. Switch the x and the y, so it becomes x equals 10y. And then solve for y. So divide both sides by 10. And I have y is equal to x divided by 10. Okay, so if I wanted you to graph these, since we are using our graphing calculators, all you would do is graph both of those, which I will do now. Get this. All right, if you want, it's always a good idea just to clear the calculator when you haven't used it in a while. So second plus 712 just kind of gets rid of any kind of funky settings that you may have going on. So the first equation is y equals 10x, and the second equation is x divided by 10, x over 10. And then I'm going to graph. And there's your original function and then your inverse function. All right, let's go ahead to the next one. Okay, so for this next one, actually, let me just up a little room below. All right, so the function that's given is y equals -1/5 x minus 7. If I want to find the inverse, I'm going to switch the x and the y. So x equals -1/5 y minus 7. And now I need to solve for y. So add the 7 to the other side. So x plus 7 is equal to -1/5 y. Then multiply both sides of the equation by the reciprocal of the fraction. So -5, or -5 over 1. All right, -1/5 times -5, they cancel. That simplifies to just a 1. Distribute the 5 into the parentheses. So I have -5x minus 35 is equal to y. All right, so the inverse is y is equal to -5x minus 35. Okay, so now when I go to graph, and hit y equals, clear out those two functions. So the first is y is equal to -1. Oh, I forgot the negative. Let me go back. -1/5 x minus 7. And the inverse is -5x minus 35. And I'm going to go ahead and graph. And there is the function and its inverse. All right. Now these are both linear equations, so you should easily be able to graph them on your own, but with a y-intercept of -35, I would have had to change this. So we're just using our graphing calculator for today anyway. All right, and then number 6, so the function that's given, which again is a linear function, y equals 3/4 x plus 5/8. To find the inverse, I'm going to switch the x and the y. So x equals 3/4 y plus 5/8. Then I'm going to solve for y. So subtract the 5/8 from both sides. X minus 5/8 is equal to 3/4 y. Then you're going to multiply both sides by the reciprocal of the fraction. So multiply both by 4/3. 3 over 4 times 4 over 3, that simplifies to just a 1, right? It would be 12 over 12, which simplifies just a 1. Distribute the 4 thirds. So you're going to have 4 thirds x minus, now you can distribute and then simplify, or you can cross simplify first. If I want to cross simplify, I can see that 4 goes into 4 once, 4 goes into 8 2 times. So 1 times 5, which will give you a 5, and 3 times 2, which will give you a 6, equals y. All right, so go ahead and graph those two. So the first function that's given, the linear function, I need a fraction, alpha y equals, get your fraction, 3 over 4 x plus alpha y equals again, 5 over 8. And then the second function is 4 over 3x. Oops. Hit the wrong button. Go back here. Alpha y equals 4 over 3x minus 5 over 6. Oh, what am I doing? Sorry. What I was clicking, 5 over 6. All right, and then I'm going to graph. And again, your two lines, you have your function and the inverse of the function. Okay? All right, so that is the graphing portion. Let me just delete that extra space. Okay. Next, 7 through 8, it says determine whether each pair of functions f and g are inverses. Explain your reasoning. All right. So for this, what you're going to look for is if the x and y coordinates have been switched, right? If we're switching the x and y's to create the inverse function, if that's step 1 of finding the inverse function, then when you're given data points to determine if they are inverses of each other, all you simply have to do is look to see if the x and y values have been flipped. All right. So if you look at the x values here, -4, -3, -2, -1, 0, 1, 2, and I can see it's been switched. Those are now the y values. And the y values from the original function are 17, 13, 9, 5, 3, 1, -3, which are now the x values. So for number 7, you can say that yes, fx and g of x are inverses. And explaining your reason, you can simply say the x and y coordinates are switched. All right, what about number 8? So I have for the x values 1, 2, 3, 4, 5, 6, which are now the y values 1, 2, 3, 4, 5, 6. All right, and then these x values should be the new y values, -1, but this should be a -2, this should be a -4, this should be a -5, this should be a -8, this should be a -10 in order for them to be inverses. So here, no, f of x and g of x are not inverses. And as far as the reasoning, you can simply say the x and y coordinates are not switched. Okay. All right. 9 and 10, find the inverse of the function, then graph the function and its inverse. So I'm going to skip the graphing portion just because you are using your graphing calculators for this part, but I will go through finding the inverse of each function. Okay. So for number 9, you're going to, same process, first change it to y equals x plus 2 cubed. And now you're going to switch the x and the y. So to find the inverse, We're going to switch the x and the y. So it's x equals y plus 2 cubed. And then solve for y. So to solve for y, I have to take the cube root of both sides. So the cube root of x equals y plus 2. And then subtract 2 from both sides. So y equals the cube root of x minus 2. All right. And then you would just graph this. Okay. It's easy enough to just plug this into the graphing calculator, plug this into the graphing calculator. All right. And then you'll be able to see your graphs. Number 10. Okay. You're given that f of x is equal to 1/3 x to the 4th. And then you're given a restriction. It says that x is greater than or equal to 0. That means on the graphing, actually, I will just quickly put this on the graphing calculator for you guys. All right, so let me clear that out. Okay, so alpha y equals, to get my fraction, 1/3. And then what is it? X to the 4th. X to the 4th. And I'm going to hit graph. Okay, so the restriction is that y has to be greater than or equal to 0. So that means when I graph, I'm not graphing this entire function. I'm only graphing the part of the function that has x values that are equal to 0 and greater than 0. So I'm talking from here. If you can imagine that I can trace on top of it. Let me try that again. So I'm going to graph from here over. Okay, this is the only portion of the graph that I actually want. All right, so if you want, you can always go to your table. So let me go to the table for a second. And I would not use any of the x values that are negative because the restriction says that x is going to be equal to or greater than 0. So I would use 0, 0 for graphing purposes, 1 and 1/3, 2 and 16/3, 3 and 27. All right, those would be the points that I would use to graph. Okay, now to find the inverse, we're going to first write, where's my pen? Y equals 1. Sorry, my pen's being weird. 1/3 x to the 4th. I'm going to come on. To find the inverse. All right, let's try this again. To find the inverse, I'm going to switch the x and the y. So x equals 1/3 y to the 4th. And I'm going to solve for y. Okay, so I'm going to first multiply both sides by 3. So 3x equals y to the 4th. And then I'm going to take the 4th root of both sides. Don't forget your plus minus. I have y is equal to plus minus the 4th root of y. Okay, and then the same restriction is, that should be an x, not a y. I'm like, why do I have 2 y's written? X, nope, that should be an x over there. Let me do that last step again. I didn't write the same thing. Take the 4th root of both sides. So it's y equals plus minus the 4th root of 3x. And the same restriction, x has to be greater than or equal to 0. Keep in mind, since this is a 4th root, right, you can't take the 4th root of a number that's less than 0, of a negative number, not at least in our real number system, okay? So you need your x values to be greater than or equal to 0, okay? And that goes back to the very first, not the very first thing, but after we wrote the definition of inverse, in notes, remember I had you write, when a real function contains an even index root, you must restrict the domain of the inverse because it's a parabola. Okay, so that even index is telling us that we need to restrict the parabola. Okay. All right, and let's see what else we're going to do. Oh, get rid of the extra space. Okay, use the graph to determine whether the inverse of f is a function. Okay, so how would I determine, just looking at the graph, how would I determine if this function has an inverse? or if its inverse is a function, I should say. This is where you're going to use the horizontal line test. So the horizontal line test. So for the horizontal line test, you draw a bunch of horizontal lines and you only want to see each horizontal line intersect the graph one time. So here it doesn't pass the horizontal line test. So if it doesn't pass the horizontal line test, that means that the inverse is not a function. So inverse is not a function. And how do I know that? It does not pass the horizontal line test. I'm just going to abbreviate HLT. Okay, what about the next one? Does this pass the horizontal line test? So far, so good. Oh, not good there. Well, first off, I'm not even drawing straight horizontal lines. Let me try that again. Right, that's fine. That's fine. But up here, is that horizontal line going to intersect the graph at like 3 spots? 1, 2, 3, right? So this one also is not, the inverse is not a function. So the inverse is not a function, and it's for the same reason. Does not pass the horizontal line test. All right. And the last bit. Okay, so for exercises 13 and 14, determine whether the functions are inverses. There is a hard way to do these problems and an easy way to do the problems. If you look in your textbook, I believe it's the harder way that they show you how to do the problems, and I'll explain it quickly. But what you want to do is you want to show that f of g of x is equal to x, and that g of f of x is equal to x as well. Okay, that's a more complicated way of doing the problem. I'm going to show you the easier way. The easier way would just be take one of the functions, find the inverse of it, and see if it is the other function. So what I mean by that, just like we were finding the inverses above, if I give you f of x, let's just find the inverse of f of x. All right, so to find the inverse, remember y equals 4x over 5 minus 1. You're going to switch the x and the y. So x equals 4y over 5 minus 1. And then you're going to solve for y. So add 1 to both sides. So x plus 1 is equal to 4y over 5. Then multiply both sides by 5. Multiply this side by 5. Multiply this side by 5. I'm going to distribute the 5 in. So I have 5x plus 5 is equal to 4y, because the 5's cancel here, and then divide both sides by 4. So I have y is equal to 5x plus 5 over 4. Is this the same thing as what I have here for g of x? Right, here's g of x's. Are they the same? No, right? This should be a 5. It's close, but it's not the same. So this is the inverse of f of x. So this one can't be the inverse of f of x. Okay? Any questions? So for this one, you would say not an inverse. All right, let's try 14. Same thing. This is the easier way of doing it. If I give you two functions, take one or the other. It doesn't matter which one. I'm going to take f of x, and I'm going to find, can hang with me while I do that. All right. So let me see. I have y is equal to negative x minus 2 raised to the 5th plus 6. I'm going to switch them. Y minus 2 raised to the 5th plus 6. Then I'm going to subtract the 6 from both sides. So x minus 6 equals negative, oh, I think I did make a sign error. Negative y minus 2 raised to the 5th. Then divide both sides by a negative 1. Yeah, somewhere on the last time around, I did make a sign error. that I'm catching now. So it's negative x plus 6. I don't know if I forgot to divide by there, equals y minus 2 raised to the 5th. And then I'm going to take the 5th root of both sides. So I have the 5th root of x plus 6 equals y minus 2. All right, just like I did the last time, since the g of x function has a 1/5 power, I'm going to switch that. So it's x plus 6 to the 1/5 equals y minus 2, and then add the 2 to the other side. See, now I made another sign error. I lost my negative. Oh my goodness, guys. See, it's negative there, and I didn't write it as up here. Move the 2 to the other side by adding it. So 2 plus negative x plus 6 raised to the 1/5 equals y. All right, flip everything around just so it actually matches. So I have y equals 2 plus, and can flip these around and make it 6 minus x raised to the 1/5. And now, because I knew it was supposed to, it does match. Okay, so take back what I said before. They are inverses of each other. All right, as long as you don't make sign errors like I made on that one. Sorry about that. They are the same. Okay. So be careful with your signs. Easy to make sign errors. All right, guys, that is it for this last lesson. So I will see you back here for the next one. Bye.